Hello, I've had a question in Unit 2, Lesson 1 for the 4U Physics. Question number 18. So we have a 35 kilogram box needs to be lifted to the top of the loading dock. So just a quick diagram here. There's my loading dock. There's my box. It's also accessible by a ramp. So ramp here. The ramp's 5 meters long. It has a height of 1.7 meters. So definitely not to scale there. A, what minimum force is required to lift the box straight up? So for A part, if we look at the box here, we want to lift it straight up. So our force of lift. In order to lift it, what are we fighting against? Well, from our free body diagram, the only thing that is acting down on this box is gravity. So that tells me that my equation, force due to lift, is equal to force due to gravity, mg, or 35 times 10, and that gives me 350 newtons. So that is the minimum force required to lift the box. All right, B part. What do we got? What minimum amount of work is required to lift the crate straight up onto the loading dock? So we are going to move the crate from this height up to that height. So that means we are going to change its gravitational potential energy. All right, we're changing its elevation. So that means that the amount of work is going to be mgh. All right, so we have 35 times 10 times 1.7. So that gives us, whoops, my calculator. Try that one more time with mine. I get 595 joules of energy. So therefore, blah, 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 595 joules of energy. So that's what the minimum amount of work is. Now, that's always the most efficient if you can do a deadlift to move an object from here to here. But it doesn't provide us with mechanical advantage because in order to do that lift, you'll need to exert 350 newtons of force. And if you aren't able to do that, and obviously that's not an option, so your next option is to use a ramp. Ramp reduces the amount of force required. That's why ramp is one of our simple machines. It gives us mechanical advantage. However, when we look at it in terms of work, whether the crate starts here and ends up here, or we lift it straight up, in either case, the crate is going to have a displacement of 1.7, which means that no matter which method we choose, the same amount of work is being done. So work equals force times displacement to push it up the ramp, but we're going to use 595 joules. That's what's going to be required to move the crate up that elevation, no matter which method we choose. Now, when we do it this way, though, you'll find that 595 divided by 5 gives us 119 newtons of force. So instead of needing 350 to complete the job, we can do it for 120 newtons of force. You're still doing the same amount of work. You're moving that box up an elevation of 1.7 or an altitude change of 1.7. Same amount of work is being done. However, mechanical advantage allows us to apply a lot less force. All right, so hopefully that answers your questions. If you have any other follow-ups or you want anything specifically answered, let me know, and talk soon.